pretty much covered a lot of the notes. There's only a couple of things I want to talk about. So we'll whiz through them as quickly as we can. So we're on about week. Where are we? We've gone through cross sections. We're now on to quantities. Now this is a pretty good example. We have the road and we have A1 plus A2 divided by 2 times L. L being the length between each one of those areas. I keep going back to this. I'll go back to this a bit later on. This shows you that there is quite a variance under the road of what the shape looks like, and you do need something to kind of balance that out. And what the Prismoidal calculation sheet will do is it not only balances out, but it averages as you go along the road. So if you get a long length, then a shorty, it kind of averages the lengths out and it averages the areas out. So it ends up with a much more accurate calculation. So in other words, as an example, if we were looking at these distances in these areas, when we apply your normal end area calculation method, a la Roger, you get a number of 9502, and then when you do it with the Prismoidal method, you get 9275. Now it might not look like much, but that's 227 cubic meters. Now that even doesn't sound like much either, but it's 6 cubic meters per truck. So if you divide that by 6, you're probably looking at 50 trucks. Now that's a lot of trucks stacked down Carrington Road waiting to take dirt away, right? And you're in charge. Each one of those, goodness knows what it costs for a day for a truck. A lot of money. Anyone that knows anyone in the trucking business is always complaining about rush hour traffic and all the costs and all the reason. So as an engineer, if you can get that calculation close as possible to the correct one, then when you ring up and say, oh, we only need 5 trucks today, or we need 2 diggers and 10 trucks, or we need them for 4 days, or whatever. So subcontractors are, most engineers I talk to say subcontractors are the worst people to deal with. But if you give them the right information, they'll work with you. So if you say to them, hey guys, I've just done the calculations, we're going to need 10 trucks on Thursday and probably about 6 on Friday. They'll go, cool, I've got another job to go to on Monday, that works out perfectly, right? But if you suddenly say to them on Friday, look, I was wrong, I calculated wrong, I'm going to need the trucks again on Monday, they'll go, no, it's already booked with another company on Monday, you have to go and find another trucking company to do it. So your job gets on hold for a week or something like that, just because you made the wrong calculations. So there's a lot of pressure on site to get these calculations right, and there's a lot of pressure on design office to get it right in the first place. Okay, here's your biggest clue to the compaction factor. We're going to use the 25, I'll zoom in a bit more on that for those at the back. We're going to use those compaction values on our assignment. So if you're not here today and you know someone that's not, you can sell that information. At least $10, I reckon. Well, that'll be 5 to me, 5 to you. Doing it? We don't get paid very much. Yeah. Favourite colour is red. $100 note. Yeah, so the compaction factor there is 25%. I've already talked about little Johnny. Maybe I have, I can't remember, when he's trying to squash down the dirt into the ground. The compaction factor is how much any particular soil or clay will compact. Alright, so it applies really to a pile that you're pushing or compacting into a hole. So it's sitting there and you can actually compact this particular clay 25%. Now when you dig it out of the ground, you get what's called a bulking factor, which means that, think about ice cream, right? You go to get an ice cream and you've got a tiny little scoop and you go, oh, I have 2 please. And they go woof, bang, and you've got this ice cream about this big and go, huh? How come it's that big? Because it's blowing up, because when he did that, there was air got inside and everything else. Sometimes they bang the top of it to try and squash it down a bit. So the compaction factor is a bit like when they give you an ice cream, all right? It bulks up until it starts melting. So with that information, what do you apply to the cut? What do you apply to the fill? And it isn't just a straight balance at the end, by the way. You can't just go, oh, or just add 5%, or take 5% off. You just got to think about that with respect to the cut and the fill, all right? And that's your extra 0.5 of a mark. Now, if you want to get that extra 0.5 of a mark and you do the calculations, I want that in your notes on your proposed plan down the side. Just make another note, and I don't want a number. I do, but I don't want it just a number. I want you to say compaction factor, blah blah, bulking, blah blah. Apply this to this, apply that to that, and final answer, blah blah. All right. You can do it on a spreadsheet pretty reasonably quickly if you do the right one. So a few options there. It's easy to get that one wrong. We were talking about balancing quantities. Most of the time you can't increase or decrease the batter slopes because the geotechnical engineer sets them at 1 to 1 or 1 to 2. So it's very hard to do that first lot. But what you can do as a designer normally is to raise or lower the platform or the road to get your balance of quantities right. Okay? Now, a lot of students come back to me with this and they say, look, Roger, if you had just raised the platform a little bit, it would have been a better, or lowered it, it would have been a better balance, right? But unfortunately, I'm setting the platform level as it is. Mass curve diagrams, they can be a little bit hard to explain. There is questions on all of this in the test. There's I'll pluck little questions from everywhere on this week's notes. But the biggest thing to think about with a mass curve diagram is looking at that, which is the best way to, if you were doing that road, would you start from 150 or would you start from 400 and come back the other way?
You cut out the way and use it to fill it up. Start at the half point and go back.
So the answer is?
Yeah, start at 450.
You start at the 400 and come back. Yeah. All right. So that's my half mark gone for today, guys. By the way, I mean, he was $100 in my top pocket was quite good before you arrived, but
well, I didn't email you for the first one, so I'm hoping I can email you for this one.
You've got till midnight. Yep. You know on the game shows when they say use it or lose it?
Yeah.
Yep. That's what lose it means. It's the wrong way around. You might. Okay. Let's hope you don't end up with 49.5 for the course.
Yeah. He gives the mark. You did for last semester also, right? Like 0.5 marks.
Yeah, if you get 0.5, they don't like that at the examiner's meeting. I get told to come back and find it. It'd be easy for him. I just go, oh yeah, that's right. He did answer a question.
Yeah.
Right. But for you, I might go, oh, put him down a couple of marks. You'll never know. 48. No, we do. We get told that the really close ones we have to go back and have a look and see if we can tie a little bit more. The theory is you've been in every class, so that's why you should clock in all the time. You've been to every class, you've sat through 3 hours of blah, 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 and you've got really close. Can we push them over the mark with 1/2 mark or something like that, or 1 mark? Once you're under 48, that doesn't happen very much after that yet. And not on the exams, because the exams, the minimum's 40, so 39 is not, I mean, you wouldn't want your doctor or surgeon to get 39% in their final exam. That would be a bit of a problem, wouldn't it? So, back to this, that is correct. So what, and I'm not going to call him the gentleman this time, what was your first name?
Lance.
Lance. Excellent, Lance. What Lance was trying to say is that when we start from here, we start cutting this out, right? So that becomes fill that we can use. And so we start putting it into here, and then obviously probably not quite enough, so at the end we're going to have to go and find some fill to use, right? And that's what a mass curve diagram is all about. So if you're working on site, you often have to do this multiple times all the way along the road. So that's why you see, when you see a long length of road being built, they've grabbed this, they've put it in a stockpile, they've moved on to another section, they're digging that out, they'll put that in the stockpile, they'll grab that, they'll put that back in another bit down there. They're always working out the easiest way to use the cut and fill along the road. So it's kind of like a work in progress, right? The other thing is you don't have all the issues. If you balance cut and fill, you don't have iwi issues. You don't have environmentalists turning up and having those issues as well. You don't have issues with a lot of things because you're using the same stuff to build your road or your platform. You don't have to bring in clean engineering fill, that costs big money.
Green
All right.
stars as well, if you do that.
Yeah. Yeah. You're also getting carbon bonuses because you're not spending money, carbon points, taking stuff away or bringing stuff to site. So yeah, it's the planning that goes ahead. It's really important in terms of earthworks. And so we use a chart that looks something like this. So I'm just using that diagram there. The way how the chart works is that if we were starting at 400, we would start building up our fill until we got to, back here to read it, around about the 320 mark, I think it is that right, where it's balanced? So that'll be 320, where we start going the other way, and that then would go probably guessing around about 200 here, and then it would end up sort of like that. So that would be your final one at 150. So this is the area that we would have to go and get some more fill, right? If we didn't start the same way as Lance suggested, and we started at 150, then immediately we would need fill, and we need quite a bit of fill, and around about here at 320, it would start going the other way, but it would never actually balance anywhere. And it would still end up on that same number here. The trouble is, pretty much all of that is needed an extra fill. And that's called, what's that? Common sense, I guess, but it's also, there's a name for it. Which is in the notes, and it's just here. That is called a mass curve diagram. So you've got the balancing of the quantities on site, and you've also got a work progress chart where you have all the subcontractors here, listed here, and you have the weeks, week 1, week 2, week 3, and it's like a bar chart. So this might be the surveyors, they might be there till then. This might be the digger driver, he might come in about here and do a bit of work. Then there'll be you'll need the trucks on site sort of to about there. And then the next one that comes on site might be the council to make sure you've done everything correct. They're all booked in for here. And then they start their next bit of surveying at that point, and then so on. The problem is if you get a wet day, everything moves a day, or if a contractor doesn't show up, everything gets blown to bits, everything moves on again. So there are multiple issues with the workload, and somehow you've got to also work in with balancing your quantities. It's all very well saying we'll just cut into that bank. You can't do it if the diggers aren't on site, can you? You know, if they're already booked out somewhere else. So spare a thought for those people on site. There's quite a few pressures. There's other pressures too. Traffic engineering department can arrive and go, you know, there's 2 of your cones are blown over. We'll close the site down for the day. Not quite that bad, but I tell you what, if they're all blown over, they will get very angry about it and close you down as a sort of punishment. And the other ones is OSH. OSH can turn up, they can see somebody working without a vest on or a hard hat, close the whole site down for a day, maybe 2 days. OSH is the health and safety people. So yeah, that's the last thing you really need to turn up on site. Also, as an engineer on site, you need a hazard board about this side, which sits outside your site office, and it's got all the hazards for the day, should be written down there. The things that could cause someone to have an accident of some sort. So you do sort of bully the contractors, because if they're doing things that could be a problem, both for you with your workload, with the quantities, or with the hazard board, you've got to bully them to make them do what you want. I mean, they might be, oh, we've been doing diggers for 20 years, you don't know anything. But the minute there's a problem on site, guess who they're going to blame? Not my fault. Yeah. So the mass curve diagram, as I've drawn down there, the properties of the mass curve diagram are pretty obvious. The most obvious one is that middle line is where they balance 0, 0. And in the second attempt, we didn't really get anywhere near a balance on that one. And there's some common terms here which I will be testing you on. So this is quite a good page to have open in the test. There's quite a few of my questions come from these week 5 notes, okay? So if you've got your test open, you've got your notes open. Now, by the way, it is an open, it will be in class, this class, the test. The morning of the test will be revision. We will then have a small break, which will give you a chance to talk about the revision with your friends in terms of, I didn't understand that, or oh dear, I didn't study that leading up to this week. How did he do that, or whatever. You can also ask me to go over something again if you want to. At that point, you will then have an open book test, but there is obviously no talking between you, and you can still sit next to each other, because there'll be random questions. You'll never get the same one probably any more than these ones. 20 questions, half a mark a question. Okay? You have to be very, very careful of how you put the digital points in there, because Moodle will go, oh, we didn't, or she didn't round off to 2 decimal points. Wrong here. Okay, so Moodle's quite particular like that. So that mark will be available possibly within 1 or 2 days when I get a chance to process it, the following week. And I get it automatically, but the problem is you know, some people don't turn up, and the numbers get skewed, the test, your names get skewed with my spreadsheet that you're gonna see in a few weeks' time. So I have to, with 120 students, because the others are all sitting a similar test on the same day. And this is my famous prismoidal sheet, which we're going to do a class exercise on, and I'm going to show you the sheet in more detail. This is only a screenshot of it. So we have the distances, we have the end areas, which is the ones at the other end there. We have the average sum of the end area, which is a calculated number. We have the interval, and WAMO, it'll calculate right down the bottom there the balance of covered fill. It goes through a process of calculating the end area, the correction factor, and then the final corrected quantities. I only need to see that bit there on your assignment. So it's only a case of highlighting it, right mouse copy, into CAD, right mouse paste. Or Control V, Control C, Control V. Yeah. Okay, so I'm going back to Moodle now, and somewhere. What I want you to do, I think I've made that available, have I? Let's have a look. Week 5. Mass curve, volume calculation. What we don't have there is okay, how am I going to do that? What we don't have is the prismoidal calculation sheet I was about to give you. So I'll have to get that off the diplomas, sorry about that. We'll just get that and I'll put it, make it available to you. And I'll show you what it looks like. Okay, so let's put that there. And prismoidal lab exercise. There it is. Oh yeah, that works. Right, so back to your course. There's that already. Design drawing. Week 5. So we'll add a folder and we'll put it all in the folder, right? Just call it week 5 class exercise. And we will drag it in. Okay, so it'll be that one and okay, that's it. And so you should be able to see that now in Moodle. Week 5 class exercise. So the prismoidal looks like this. Go over it, and then I'll let you loose on that class exercise. can you open that please yourself, your, the spreadsheet? Alright. I'm gonna colour code this, so you might like to, my suggestion, because remember this is gonna be in the test, and by the way, the Prismoidal is a couple of compulsory questions in the test. So with Moodle I can say, oh that's random, about 120 of those, so it'll pick different ones for different students. With the non-random ones, the mathematical ones, I'll say I want 3 of those out of there, and I want 3 of those, and I've picked 2, at least 2 of these for the test, right? So I'm not joking when I say that there will be a couple of questions on this, so best that you concentrate on this. The sort of questions I might say is, how do you find the average sum of the end area? And then there'll be 3 or 4 options. Whereas if you colour code yours now and take it into the test with you, open book, remember, it might be very easy and quick to find that. Okay, so the first thing I need to tell you is that these numbers here are what you will be inputting yourself into for your assignment. The distance is this accumulative, so that adds up all the time, boom, 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 all the way. The cut and fill are over there, so the left hand side is the fill, the right hand side is the cut. I just made some numbers up over there, right? It doesn't really matter, you understand what I mean. And the interval is these ones here. Now, like Lance asked me, like, what is that interval? And I said, well, you can do it whatever is convenient for you. I suggest that it's a lot easier to draw a cross section through this line, these 2 lines either end that go through a contour. Makes life easy. Don't have to, you can do very even all the way if you want. There's no advantage in being even, just remember what your distances are when you plug them into there. That one there is kind of, well, the reason for it being 10 is just to make life a bit easier in understanding it, all right? The example I'm going to give you doesn't have even intervals like that. Now do notice that the first one starts on 0. If you're doing a road job, to be honest, it never starts on 0 unless it's a brand new road. They usually start on some funny number because you're working along an existing road. You know, you might be outside house number 35 and the chainage down the road might be 68.2 or something. Yeah. So that can be very confusing when you first start in engineering because you keep thinking we should be starting at 0, right? So there's a 0 there, and in this case 0, 0 for cut and fill. So obviously merging the road into another road, or they're starting from a point where they want it to be 0 cut and fill. So that's how that's recorded, and then from then on down, it's at even intervals to the final point of 110. Now you can see there that doesn't actually match perfectly with cut and fill. So that's going to be about 8 to 10 mils difference on the road surfaces. That's not too bad. So that column's quite easy to work out, okay? What is the average sum? Well, the average sum is also always thinking about the one before and the one after. So what I'm going to do here, just in case it's a bit confusing, and you probably would pay to do this yourself, is right click on that and go format cells and go to the number and then go to 3 decimal places. Did that work? I'll make it 4. Format cells, 4 decimal places. Yeah, 4 is probably better. Alright, so that number 0.33 refers to that plus that divided by 2. So it's an average sum of the end area. So this number here in the cut, 0.31, refers to the previous, that's fill not cut, the previous fill, and the fill we're on divided by 2. Right? The next column we've already talked about, the quantities. Quantity of cut equals 10 times the average end area. We do a fill, that quantity of fill equals 10, in this case the interval, times that one there.
G7 times G7,
Alright? Now, up till around 1960, that was fine. That's how they did all their quantities. They didn't have spreadsheets. They just did it as a calculation, similar to my one up the top there. And that's how they worked their way along the road. When they discovered the errors for wedges and prisms and stuff, and of course spreadsheets started coming into play in the 80s, late 80s, early 90s, computers, everything else, they came up with the end area ratio, and from that they calculated the correction factor. By the way, let's have a quick look at we'll do the end area ratio first. How can I explain that to somebody to try and put it in their brain? Okay, when you come in from the Pacific Islands and you've been out there all week on holiday, eating coconuts and eating bananas, and you leave a banana in your bag and you come through customs, what happens? $100 fine, is that right? Have you done that before? $400 fine, okay, no, okay. And if you decide to run through customs with the banana in your hand, holding it, eating it, and try and run through the outside, what happens then? The big customs guys come out and jump on you. And I can tell you that because, not because I've eaten a banana, but because my daughter was having an argument with me. She's about 14 at the time, she's 30 something now. And she was with her friend coming back from the islands, and she took off. I said, stop, no. She took off. And of course they ignore children, and the customs guys said, and I had her bag. And he said, did you pack that bag? I said, no. And he says, oh, you better come this way, sir. And I said, no, she packed it. And I says, oh, come back. And of course, the more I yelled, the more customs guys came out of their offices. And they thought, oh, he's a fairly big guy. I think we better send all the big guys down. I looked, turned around, there's guys bigger than me and wider than me. And they're all going, come this way, please, sir. So I think of that and I think, well, they would have bullied me, and I think I would have ended up on the bottom. Let's take a scenario where I had all the $100 that students had given me and I paid them off, and I walked through with the banana in my hand. That is reversing the situation. That is me on top. So if you think of me paying the customs guys off and getting through customs, that is exactly what the ratio turns out to be. So the ratio here is always that number there, these two, the one before, the one after, but the highest number goes on the bottom, or the lowest number on the top, which is me going through customs with the banana. If you didn't like that explanation, then you use an explanation that Lucia would give you, which is ratios are always less than 1. Okay, so to make it less than 1, you put the little 1 on top. Let's do another one. This one here. No, this one. That's the area of fill. That's the ratio, end area ratio of fill. It'll be those two. Which is the smallest one? The bottom one. 0.213 divided by 0.60656 equal 0.324. The next one, you're expected to learn off by heart the formula for the test. You right with that, Lance?
Sorry?
You're expected to learn that formula there for the test.
The top of the spreadsheet.
Yep.
Ah, yeah. You're pulling out later.
Now, yeah, luckily, Lance isn't a person who gets stressed very well. He's actually 100% right. You don't need to do that for the test, okay? I would never make you do that. So keep the camera rolling. Don't just do that bit where I said you got to do it for the test. Don't want to see you in trouble, or me in trouble. The correction factor is ignored in all my questions. It is a formula that I said was written by the mathematics world champion. I don't want to, but you need to know that it's quite complicated and it takes into account the end area ratio and also the distances, the cuts, the fills, and all the rest. Now from that correction factor, we can now come up with a new cut and fill area, and so therefore just looking at that last one, that for example is going to be equal to that times the original quantity. There's not much difference. That's 0.777, that's 0.7738. We'll take one that there is quite a bit of difference in, shall we? This one here, 0.222, and that's that number multiplied by 0.333, 0.033. And of course down the bottom, if it says 4.806 fill, that's a fill. If it says negative 4.86 fill, that would be a cut. Because it doesn't have the ability to change that letter, that text. Okay? So it's either going to be a negative number there or a positive number. A negative number will be cut, and you can see which one's the greatest anyway. Obviously, this one's the greatest, which is fill. So, all of that done and said, here's your little lab exercise. Do not look at the bottom. That's the answer. What I want you to look at is the top. And I want you to look at this table here. So the chainage starts at 190. Chainage is the distance, a survey term for distance.
24.
The cut and fill are the little things that you worked out there. You'll have to work out the interval yourself, and you have to look at my last example. You can use that spreadsheet actually, use that one, and see how you get on. See if you can get the same answer I got. Now you will get errors. The errors can be changed into noughts, or they can be deleted. So I'll give you about 5 or 10 minutes to do that. I'll start setting up the AutoCAD thing I was going to show you. Don't need to film anymore at the moment until the AutoCAD comes. Yep.